notice, you'll see this, these notes here, more multiplication properties of exponents. What we're talking about here is that we are going to be multiplying, but now instead of just regular multiplication, we're going to be using exponents. So remember, I showed the kids in first period, see this expression here. 2 to the second power times 2 to the fifth power is 2 to the seventh power, right? That's what we've been doing now for several days. But now, and then you can see here that x cubed plus x to the fourth plus x to the negative second, we learned that you add all of those exponents to simplify them. That is the shortcut. That's not adding, that's multiplying. That is the shortcut for multiplying, just adding the exponents, right? Today, we're going to be looking at an expression that looks like this. So we have a power, so 2 is raised to the second power, but then there's another power. And we call that a power to a power, or a power raised to a power, okay? So there's a shortcut for that as well. Now, before we learn the shortcut, remember, if you choose something, whatever the base is, it's a factor 3 times, right? This base happens to have an exponent, right? So this is the same as 2 squared times 2 squared times 2 squared, right? Because it's 2 squared 3 times. Make sense? So we can add those exponents and get 2 to the 6th power, but we can also use the shortcut. And the shortcut here is, if it's a power to a power, we'll be multiplying. So if it's just a regular base times a base, we add. If it's a power to a power, we multiply. So that's what we're talking about today. So let's go ahead and get started in our notes. When a power is raised to another power, like x to the y power raised to the z power, we multiply the power, multiply the exponent. So when we read as a power, that means that's the exponent. So look at the next example. If you can't see it great as far as little exponents, remember you have the same thing on your desk. It's c to the 3rd power raised to the 4th power. I had a teacher back in the old days when I was in school, and she would refer to this as a power to a power. To help remember the difference, she would say up high, multiply. So if you get a power and then a higher power, you're going to multiply those to that shortcut, right? So what is the simplified form of d cubed raised to the 4th power? Well, we're going to multiply there. So that would be multiply the exponents and then simplify. Sometimes you're going to have expressions that are just like bases times like bases in the same expression where you have a power to a power. We're always going to do the power to powers first. And let's circle first. So do your powers to powers, and then we do what we've been doing, was multiply the like bases by adding the exponents. So like bases, we multiply by adding exponents. Powers to powers, exponents raised to exponents, the shortcut is to multiply those exponents. So if we have n to the 3rd power raised to the 6th power times n to the 4th power. This is one that you're going to have some like bases times like bases, and then powers times powers. The first thing we're going to do is we're going to simplify that n to the negative 3rd raised to the 6th power, because that's the power to a power. And the shortcut for that, remember, is that we multiply that. So we're going to rewrite what we have now, n to the negative 18th power times n to the 4th power. So for it to be simplified, we can't have any like bases, we can't have any exponents that we could evaluate. We need to multiply everything that we can multiply. So this is not in final form though, right? So what are we going to do? Well, we're going to multiply the powers of the same basis by adding the exponents. So now you see that we have n to the negative 14th power, and we're going to write the expression using positive exponents. And we're going to move any negative exponents to make them positive. So the final answer, we've got n to the negative 14th power. Since it's a negative, we know it's going to be a fraction. We're going to make it a fraction. And then we move anything that has a negative exponent. If it's in the top, we move it to the bottom and make it positive. If it's in the bottom, we move it to the top and make it positive. What do we put in the top if there's nothing left up there? 1. And that's your final answer. Okay? Not a lot different than what we've been doing. Any questions so far? Okay, so we have used scientific notation. We've been practicing, we've multiplied expressions written in scientific notation by other expressions written in scientific notation, and we've practiced making sure that our final answer is also written in scientific notation. Remember, that first number has to be between 1 and 10, right? So when simplifying numbers written in scientific notation raised to a power, you must also simplify the powers to a power first. So I think, do you guys have that already? Do you need to write it? Do you need to write it? Okay. Forgot to box the second page for some reason. So this is an example of what they're talking about here. This is an expression written in scientific notation. Remember, this is the only time a negative exponent is okay. 4.2, which is between 1 and 10, we said it's got to be between 1 and 10, times 10 to some power. But that says we're going to square it. So the first thing we're going to do is we're going to take this 4.2 and apply that or distribute that power to a power. Now this is the part where a lot of kids forget to do it because there's no exponent on 4.2 that's visible, right? What is that exponent if we don't see it? It's 1. Exactly right. So now, I would suggest you go ahead and write that in before you distribute. So here, we're going to do 1 times, my bad, just wrong spot. 1 times 2, the power to a power, we multiply, and that's how we get 4.2 to the second power. And then negative 7 times 2, right there, that's how we get, they're distributing the square there, and then they simplify it here. So they're rewriting it as a squared expression, and then they simplified it here, so that's where they did the multiplication. Negative 7 times 2 is negative 14, and they've already squared, so 4, 2 to the second power. You guys want to do that on your calculator? There's an x squared button on it. Anytime you have just a squared one, it's probably easier to use the x squared button. Just do 4.2 x squared, and you should get 17.64. Okay. So is this expression, is it in scientific notation right now?
No.
What's wrong with it, Cole?
The first part of it is okay.
Right. So this 17.64 is greater than 10, right? And that's the problem. So what we're going to do, so let's go ahead and catch up our notes here. So the first thing you're going to do is you're going to raise each factor to the exponent of 2. I've got a weird thing there. So raise each factor to the exponent of 2. I've got 2x to the. And then we're going to multiply 4.2 by itself, multiply the exponents of the expression with base 10 by adding the exponents. So that's what we're getting ready to do here. So we're going to wait on that. You can write it, but we're about to do that right now. So this refers to how we get from here to here, or after we get to here. The problem is, this is not in the range of numbers it's got to be in, so we're going to rewrite it as some number times 10 to some power. And we've got to bring down that times 10 to the negative 14 power that we already have. So we have to rewrite this expression where this number is between 1 and 10. Does that make sense, Sloan? Does that make sense? Okay. Does that make sense, Naya? So, is this number greater than 1 or less than 1? So if it's greater than 1, we know our exponent is going to be positive. So that's the tricky part to me. Remembering which it is, positive or negative, right? So it's a positive. So now I'm just going to see how many times do I have to move my decimal point to get it in that appropriate range. So if it's bigger than 1, I'm moving it this way. Is 1.764, is that between 1 and 10? 1.764. If I move my decimal point right here, is that number in a range we need? So that's what we're going to do. So if we move it 1 time, that exponent is 1, we're going to write 1.764. Does that make sense, Annabelle? Does that make sense, Nicholas? Okay. Brooklyn? Yes or no? Okay. So now, that's where they get this expression, right? That's how they get it. So from there, now we add the exponent. So we've already moved this. I'm going to go ahead and put that in there. And now, if we bring down to 1.764 and we add these exponents, 1 plus negative 14, remember this is not a power to a power now. They're not two exponents right together. This is just a like basis times like basis. We add the exponents and the powers of 10 to write in scientific notation. So here it said multiply by adding, but we multiplied. I did that a little bit differently. But that's okay. All right, the last thing I want you to put in your notes is that we always move negative exponents last. When we're simplifying these expressions, we're going to do everything we can do and move our negative exponents last. Everybody get it? Everything written down? You need to go back to anything? Let's wait for a minute because I'm actually going to do some of your homework problems with you. You're only doing the even problems, so that's quite a few problems. Right, you're only doing the even ones. I think it says that on the top. Even only. But I wanted to do some problems with you. Well, go get it. There's what? Yeah, I've seen that there. Yes. Odds, I think we're doing odds Monday. You can. Sorry? Well, I'm not positive we're doing the odds on Monday, so you can do it though, yeah, if you want to, and I'll post the answers for all of it if I don't decide on Monday. Yeah. All right, you guys want to do some homework problems together so you have less to do? So you don't lose points for doing extra problems twice. Am I going to give you double credit for doing all of them? No. Do you want to look through there and see if there's some you want me to work with you, some that you think look overwhelming, maybe you don't think you saw one that looks just like it? Brandon? Number 22. So 22 is actually a homework problem. If you don't want to work with it, you don't have to, but we're going to do number 22 together, and you can write it on your worksheet, one less problem you have to do. Just a second, honey. All right, did I write it correctly, Brandon? Oh, I'm missing the 7. Thank you. Danielle? No, we're doing this problem. When we're through going over working on homework problems with these students, you go, you can. Okay? Is it an emergency? Okay. All right. So looking at these problems, this expression, it looks like there's two factors. So basically, we are going to call these two factors because they're grouped with two sets of parentheses. Within this factor, there's two other factors, right? Within this factor, there's only one. So the very first thing we're going to do is we're going to do our powers to our powers. So this power is up higher than these other two powers. So up high multiply, right? So we're going to take this m, 4 sevenths to the 7th power is 4 sevenths times 7. Let me refresh how you do that on your calculator. Throw your calculator out 3 times. 4 ABC 7 times 7. You should get 4. Now we're going to do n to the 3rd power raised to the 7th power. So that's 3 times 7, 21. So far so good, Brandon? Does that make sense, Nicholas? Does that make sense to Corey? Okay. Now this m to the 4th power is being raised to the 3rd power. So I've got another m, power to power, up high multiply. That's going to be a 12. I don't have any negative exponents, that's good, but I have two factors that have an m, so I can't be done yet. How do we simplify that from there, Brandon? So this would look like a problem from the last 2 days. These will be, we're going to multiply any like bases by adding their exponents, right? So what would we do? So m to the 4th and m to the 12th. Those are like bases, right? Okay, so we're going to add their exponents. What are their exponents? You know what the exponents are? Okay, tell me what the exponents are. 4 and 20 and 12, right. So if we add the exponents, what do we get? So the m now has a power of 16. There's nothing to do with the n because there's only one of those factors. So that's your final answer. Not right now. Now while we're going doing homework problems. Danielle's already asked. I told her she can go once we're through doing some homework problems. Look through any other homework problems you see that you want, you think would be best if we tried one together. All right, well, let's at least do one of the scientific notation problems together. So I think we did number 36 in first period, so we'll do 36 together. You can't really complain about the number of problems I'm giving you if I'm offering to work them with you in class, right? So 36 is one of your homework problems. Follow along. 6.24 times 10 to the 13th power. All raised to the 3rd power. So So once again, the tricky part here is, what is the power on 6.24? You don't see it, Jeremiah. What is it? So this is a power to a power, a power to a power. When kids don't see that one, they forget that that also has to be raised to that power. So that's 6.24 to the third power. 6.24, 1 times 3 is our power, times 10 to the 13th times 3, which is 39. Does that make sense, Keishan? Does that make sense, Anson? Okay. All right, makes sense? Okay. So on your calculator, you guys should be able to evaluate that exponent on 6.24. Remember, 6.24 y x button 3 equals. What did you get, Swan? 238? Oh, try it again. 6.24 y to the x 3 equals. Did I write something? Okay, maybe I don't remember it from first period, so I was 242.97. We're going to round to the hundredth place times 10 to the 39th power. So this equals that, and we just brought that down. That makes sense, Peyton? That makes sense, Zion? Okay. Now, is this expression in scientific notation? At first glance, you might think it is, because it's times 10 to some power. But is this number, does it fall in the correct range? No. So we're going to rewrite that expression as some number times 10 to some power, and then we can't forget we've got to bring this down. So is this exponent, when I rewrite this, is it going to be a positive or a negative exponent? What do you think, Keishan? Positive, because this number is greater than 1, this is going to be a positive exponent. So now I started the decimal point. If I go left, I'm going to make this a smaller number. That's what I need to do, because it needs to be between 1 and 10. So 1, 2. If I move it 2 places, now I have 2.4297. That is in between 1 and 10. So that's what I'm going to do. 2.4297, and I moved it 2 times, so that's my exponent on my base 10. Well, yeah. If it's a terminating decimal, it's not, but if we have to, we round it anyway, so that would be fine. All right, so now we're just going to bring down to 2.4297, right? And what is going to be the power on the base 10? What's going to be the power on the base 10, Anson? Sorry? Not 2, right? Because we have 10 to the second times 10 to the 39th. So with like bases, we're multiplying those, so what do we do to exponents? So the like base comes to like base, you just add the exponent. So what's the exponent going to be on there, Brooklyn? Diane? 41, right. 10 to the second times 10 to the 39. Like bases, when we multiply them, we just add the exponent. That's your final answer. Does anybody see a question that you'd like me to work from your homework? All right, 15, then work on your, you don't even have to be working with me now if you don't want to be. If you don't need any other questions, go ahead and get to work. So don't put your head down, all right? Kendall, 28. All right, if you want to keep working with me, we're doing your actual homework problems right now. So 28, sorry, I'm going to look over your shoulder here. 5x to the negative 5th power. Y squared times 2x to the negative 14th power squared. Is that the right problem? Can we check, make sure I wrote it correctly? Okay. So this part here nothing to do. I don't have any light spaces I can combine, no powers, no powers. It wouldn't matter. I'm not going to do that first anyway. Remember we said we're always going to do powers to powers first. If you see two exponents right next to each other, those are the powers to powers. Here there's an exponent, here there's an exponent, but here there's an exponent and another exponent. That's how we know it's the power to a power. So what's the part that people are going to forget? Can anybody tell me? I've said it a couple times now. Looking here, what's going to be the part that some kids are going to forget to do? Do you know, Trinicia? No, Zion? That there's a 1 and a 2, very good. So, you don't have to write it if you don't need to, but I'm telling you that strategy might help you not forget to distribute that power here. So now this is going to be 2 to the 1 times 2 power, x to the negative 14 times 2 power. 5? So, no, we don't have to do that because that's not in the parentheses. That's a good question. This 5 is outside the parentheses. It's not getting raised to a power. But if you're meaning, does it have a power of 1 on it? Yes, there's a power of 1 on that. That one's not as big a deal though because we're not raising it to another power. Does that make sense, Samson? That one, we're just going to be using it as a 5. So now we're going to bring down, so now we have 5 x to the negative 5th power y squared times this. And remember, these parentheses is just like multiplication. So we're going to multiply this. I mean, they're just, we don't even really need the parentheses. Times 2 squared times x to the negative 28th power. So 5 times 2 squared, x to the 5th, negative 5th, times x to the negative 28th, right? And there's nothing else to multiply the y by, so we're just bringing the y squares down. You do not have to rewrite it like this in this step. If you can do that part in your head and you don't want to rearrange them, you don't have to. But if you're struggling, more steps is better than less steps. So what's 2 squared? What's 2 squared, Brooklyn? Sorry? Yes, 4. So that's 5 times 4, which is 20. What's x to the negative 5th power times x to the negative 28th power, Ulrich? Yes, x to the negative 33, yes. And we don't have anything else to multiply the y by, so we just bring it down. Is that my final answer? What do you think? Is that my final answer, Nicholas? Sorry? What's wrong with that? What is there left for me to do? I can't add the exponents anymore. I've already added, so you only add the exponents when you're multiplying like bases. So we did that. X to the negative 5th times x to the negative 28. Anson? Put it in fraction form. Why would we do that, Anson? You're right, but why would we do that? Because there's a negative exponent left there, right? So we're going to remind ourselves, negative exponents tell me it's probably going to be a fraction. We can always start with a fraction if we see a negative. So now, anything that has a negative exponent is moved. Anything that has a positive exponent has to stay where it is. So let's move the negative to the bottom. That's how we make it positive. The 20 is to the positive 1st power. It stays where it is in the top. Y is raised to a positive 2 power. It stays where it is in the top. How you feeling? Pretty good? All right, well, we have some time to work in class. You can come ask for help if you need it. So work on it. If you have a problem you think you want to work with me, go ahead and see if you can try it on your own, just briefly, and you can come up and you and I'll work it together. Yeah. Danielle, the time is 10:08. I am hesitant to let you advance and come call you though. I'm staying. So hurry back.